All right. So this is the part 2 of that of this equation up here. We had solved it in that last video, and we were able to get it boiled down to cosine of x is equal to 1/2. And these were our two solutions that we had found. All right. So on our unit circle, for cosine to be equal to 1/2, it was going to happen in quadrant 1 at pi over 3, and it was going to happen in quadrant 4 at 5 pi over 3. All right. But we could also get more solutions if we were to, from here, if we were just to add another 2 pi to it, all right? Or if we were to subtract 2 pi from it, and we could keep doing that over and over. So the problem had this restriction on there. It said only look for the solutions that are from negative pi to pi. Right, and that's going to be the part of this that usually throws people for a loop. So I'm going to try to explain what that is. All right. You might already have like an intuition for how the angles work on the unit circle. This is negative pi. From 0, you rotate this way. So from negative pi to pi would be like this. So from negative pi, that would be to 0, and then from 0 to pi. So this full loop right here that I made is the interval from negative pi to pi. But I'm going to actually, stretch out my interval like this, like on a number line, right? So pi over 3 would be in between 0 and pi. It'd be 1/3 of the way. All right, that's pi over 3. So this is indeed a solution. All right, that is a good solution. Now, if I were to add a 2 pi to this, so you see how the distance from negative pi to pi, that's got a distance of 2 pi? If I were to add a 2 pi to this pi over 3, I'd be way over here, right? That would be outside of my interval. And if I were to subtract 2 pi from this, I'd be way over on this side. So I'd be outside of my interval again. Right? If we were in class, we'd probably be talking about it on this, but it just gets too confusing trying to point to the angles on here and knowing what I'm talking about. So, all right, so this is the only answer for my base answer of pi over 3. Like, if I was to try to add 2 pi to pi over 3, this is what it would look like. Pi over 3 plus 2 pi. So 2 pi is the same as 6 pi over 3. I would get pi plus 6 pi, which is 7 pi over 3. So this is a solution. It is a solution to this equation, in this equation. But 7 pi over 3 is way past my regular pi. All right. So that's my only answer when it comes to this. Now, 5 pi over 3 is another solution, but 5 pi over 3 is past my pi. 5 pi over 3 would be like pi plus 2/3 of a pi. All right, so it's outside of my desired window, my desired interval. So what I need to do here is I need to subtract 2 pi. All right, if I subtract 2 pi, it's going to bring me in between these two. If I added 2 pi, it'd be way bigger than what I needed to. So to get my other answer, I'm going to do 5 pi over 3 minus 2 pi, which is 6 pi over 3. 5 pi minus 6 pi is negative pi over 3. And this is going to be my other answer. All right. Negative pi over 3 is, to the left of 0. So negative pi over 3. It's right there. Okay. So, and I can't do another one. If I was to do another minus 2 pi, I'd be way over here. So that wouldn't work out. So these are my only two solutions on the interval from negative pi to pi. Where this one is, if I were to think about where that is on my little unit circle, negative pi over 3 would be rotating downwards 60 degrees. So hopefully you see that that's the same thing. That's the same thing as 5 pi over 3. All right, it's just that 5 pi over 3 was outside of my original window. All right, so